The Earth's surface is over 70% ocean. Think about that. For every asteroid that has a chance to hit land, there are more than 2 that are destined for the water. We spend billions of dollars scanning the skies for that one city-killer rock aimed at New York or London. But what if I told you the single greatest threat isn't the impact we can see, but the one we can't? What if the deadliest weapon in the cosmos isn't the asteroid itself, but the ocean it lands in? The real danger isn't the explosion in the sky. It's the silent, unstoppable ripple effect that comes after. An asteroid tsunami. Today we're diving deep into the terrifyingly plausible scenario of an ocean impact. We'll explore the cataclysmic science, the historical scars left on our planet, and why the next global catastrophe might not fall from the sky, but rise from the sea. This isn't a new fear. It's a forgotten cataclysm written into the very rock beneath our feet. 66 million years ago, a rock 6 miles wide slammed into what is now the Yucatan Peninsula. We all know the story. It ended the reign of the dinosaurs. But we focus on the dust and the winter that followed. We forget the immediate consequence. The impact created a megatsunami, a wave estimated to be nearly 1 mile high, that scoured the Gulf of Mexico and washed across the entire planet. This wasn't a story. It was a global cleansing event. More recently, in 2013, the world watched as a 60-foot wide asteroid exploded over Chelyabinsk, Russia. It shattered windows, injured over 1,000 people, and reminded us of a chilling fact. It arrived completely undetected. Now, imagine if that same undetected rock, or one just slightly bigger, hadn't hit Siberia, but had plunged into the middle of the Pacific Ocean. The world wouldn't have heard an explosion. It would have received a death notice, delivered by the tide. To understand the sheer power we're talking about, you need to know 2 key concepts that turn an ocean impact into a doomsday weapon. First is hypervelocity energy transfer. An asteroid doesn't just splash into the water. It strikes at such an insane speed, we're talking 40,000 miles per hour, that the water doesn't have time to move. It's instantly vaporized. The impact transfers the kinetic energy of 1 billion nuclear bombs directly into the ocean. It doesn't just create a wave, it creates an explosive cavity in the sea itself, which then violently collapses back on itself. Second is deep ocean wave propagation. An asteroid-generated tsunami isn't like a normal wave. Out in the deep ocean, it might only be a few feet tall, but it's a ridge of energy hundreds of miles long, traveling at the speed of a jetliner. Ships at sea might pass right over it and feel nothing, but think of it like cracking a whip. All the energy you put into the handle travels almost invisibly down the length until it's unleashed in one explosive snap at the very end. The shallowing coastline is the end of that whip. Let's paint a picture. An asteroid, about 1/3 of a mile wide, big enough to be catastrophic but small enough to slip through our detection nets, is on its final approach. It's not aimed at a city. Its target is a remote spot in the Pacific Ocean, 1,000 miles east of Japan. It pierces the atmosphere, becoming a blinding fireball that no one is there to see. The impact is silent to human ears, but the ocean screams. A flash of light, and trillions of tons of seawater are vaporized in a millisecond. An underwater crater, miles wide, is blasted into the seabed. As the cavity collapses, a circular wall of water, 1,000 feet high, erupts outwards. This is wave 0. It begins its journey. At 500 miles per hour, it's a silent, unstoppable force. It reaches the coast of Japan in under 2 hours. Tokyo's tsunami walls, designed to stop 40-foot waves, are a joke. A dark line appears on the horizon, rising not into a crest, but into a solid cliff of water 300 feet high that erases the world's largest metropolis from existence. To the east, the wave travels on. 8 hours later, the tide in Hawaii suddenly and unnaturally pulls back, for miles, exposing reefs never seen by human eyes. Then, the wall arrives. 10 hours after impact, the wave reaches the west coast of the United States. From Seattle to San Diego, it doesn't just flood the coast, it obliterates it. The water surges inland for miles, a churning torrent of debris, buildings, and chaos. not receding for over an hour. It's the single deadliest event in human history, caused by a rock that never even touched dry land. Now, some scientists and risk analysts argue this scenario is exaggerated. They claim that an impact in the vastness of the ocean would see much of its energy dissipate. Their computer models suggest that while a tsunami would be devastating locally, it wouldn't maintain its catastrophic height across an entire ocean basin. They say the sheer volume of the ocean acts as a cushion. However, this argument has a critical flaw. It focuses only on the initial wave and ignores the geological consequences. Newer research suggests the impact would be so powerful, it could trigger secondary events. The shock wave through the water could destabilize undersea mountains, causing massive submarine landslides that create their own megatsunamis. It's a cascade effect. One impact could create a dozen tsunamis from different directions. The ocean wouldn't cushion the blow. It would become a web of ricocheting destruction. And if you need irrefutable physical proof that this isn't just a Hollywood scenario, you just need to dig. Geologists have found the crime scene. When the Chicxulub asteroid hit 66 million years ago, it left behind more than a crater. It left a calling card across the globe. In sediment layers in Texas, Alabama, and across the Caribbean, scientists have found a bizarre layer of rock. It's a chaotic jumble of sand, boulders, and marine fossils all mixed together. There's only one thing that could have deposited that layer so far inland: a wave of unimaginable power and height, sweeping everything before it. This isn't a computer model. This isn't a theory. It's a physical scar, a layer of geologic evidence that proves an asteroid tsunami isn't just possible, but that it has happened with world-altering violence before. This leads us to a fascinating question about a very modern program. In 2022, the National Aeronautics and Space Administration successfully executed the double asteroid redirection test mission, crashing a probe into an asteroid to alter its course. Officially, it was a triumphant proof of concept for planetary defense. But there's an interesting theory circulating in aerospace circles. The mission was declared a success because it changed the asteroid's orbit more than predicted. What if the real, undeclared purpose of the mission wasn't just to see if they could move an asteroid, but to find out how much they could move one secretly? Imagine a scenario where a known threat is on an ocean impact trajectory. A full-scale deflection might not be possible, but a small secret nudge could change the impact point from the Atlantic, where it would threaten the US and Europe, to the remote South Pacific. It wouldn't save the planet, but it would save certain nations. It raises a chilling question. Is our planetary defense system designed to protect Earth or to simply control where the hammer falls? In the end, the threat of an asteroid tsunami is a stark reminder of our vulnerability. We look to the stars with fear, but we forget the immense destructive power of the oceans that cover our own world. An asteroid impact is not just a geological event. In the ocean, it becomes a hydrological weapon. The water that gives us life could, in an instant, be turned into the instrument of our demise. So I want to ask you, after seeing the evidence, which do you believe is the greater, more immediate threat to our coastlines? A megatsunami from an undersea landslide, or one from an asteroid we never saw coming? If this deep dive into cosmic threats has you intrigued, make sure you subscribe, hit the notification bell, and check out our other video exploring the terrifying reality of the Earth's magnetic poles flipping. Thanks for watching, and I'll see you in the next one.